back. So we're just getting a little bit of sustenance. So our next plan of attack is to reconfigure our hardware. As we mentioned earlier, there is a way that we can connect general purpose input-output GPIO pins to these DC motors, and we can use software to encode like the PWM. So that's going to help us because then we have a lot more GPIO pins than we do have hardware PWM pins, and we can now have each of these motors independently driven, and that's going to be critical for us being able to rotate. So we can actually spin it around, not just translate.
So. Yeah, and I guess I'll give you a little bit of elaboration on that. As it stands right now, our car is hardwired such that these two wheels get the same control inputs, and these two wheels get the same control inputs. Which means if these ones are going forward, if this one's going forward, this one has to go forward and backward, etc., etc. Which gives you full translation, as you can see as I'm pushing it around right now. So you can translate forward, backward. But the problem is, if you wanted to rotate in a full circle, you can see that all of the wheels would have to go in the same direction. But since these two wheels are tied together, they can't go in opposite direction. They can't reverse each other like this. That is impossible the way it's configured right now. That's because the control inputs are actually tied together in this bus. So the control inputs for this wheel and this wheel and this wheel and this wheel are all tied together so that we can save some pins on our Raspberry Pi. But we've recently learned that we can actually do, like Glavin said, the PWM can be forced through software instead of hardware. The Raspberry Pi only has 4 hardware-style PWM pins, but all of the GPIO pins can be used as software PWM. The only thing is it lessens the available frequency we have, but we're not doing that fine a calculation, so the frequencies available in software PWM are acceptable for our purposes. At least that's our theory right now, and hopefully it works on within our first few tries. There's always a chance that we're wrong, and maybe it won't work, but
yeah, we'll learn something then too.
Yeah.
Learning is good.
Learning is good. Mistakes are better. We'll remember them.
Yeah.
You remember your mistakes more than you remember your successes.
Yeah. And if it doesn't work, we just found another way that it doesn't. Just like you build a light bulb, 1,000 different ways. You can't make a light bulb until you find out the right one. So that's
Thomas Edison. Boom.
Yeah.
Yeah. I did it. Yeah, Thomas Edison. I did not fail 100 times. I found 100 different ways this didn't work.
Yeah. Good way to be.
What's interesting is Thomas Edison was an inventor in every sense of the word. And when you look at Nikola Tesla was able to design products and invent them without iterating on the process. He could design things in his head, or at least that's the way the story goes. He could see electricity so well in his head that he could design very complex systems without having to actually build them. Which is very impressive. Very impressive, depending on how true that is.
Yeah, I guess you just understood it well enough, right? That goes back to what we were talking about. If you understand something simply or understand those building blocks, you can build anything. You can truly be creative.
Mm-hmm. Truly be creative. That's the best way to put it. I agree with that. Can you find me 8 pins?
I can. All right. So, Raspberry Pi 3 A+ pin out.
So Glavin's finding me 8 pins that he's going to, in software, set as our PWM pins, and I'm going to make those physical connections from the hardware perspective. And it's really going to clean up our board, which is very exciting.
Yeah, 1 sec.
This can be completely removed.
I'm going to shrink this a little bit. I shrunk this. I don't know if it's readable by everybody though.
Somebody just joined. Should check that message.
Yeah, let me take a look.
Tetsu again? Or did it just say? It just gave us a notification. There's no actual message.
Have this open. Oh. Be able to get that hooked up.
Yeah.
I have it open from here on, but I can't get the old message. Looking good, guys. Thanks, Nacho Kitty.
Thanks, Nacho.
Did you get a chance to see our previous before we were able to pause the stream? We got it working. So we had the joystick from the PlayStation 3, PlayStation 4 controller driving the translation. So it was actually able to move it around, and it was pretty snappy, very responsive, so fast that we actually started to lose the nuts right on the bottom of the wheels. So actually, the wheel had a potential to pop right off, the motors and everything. It was shaking pieces off of it. So Lucas is now working to get that hooked back up, so it will not fall apart again, hopefully. And for future testing, we'll probably crank it down from 100% back down to 40% like we were testing before, until we get a little more solid.
Can you get me some pins?
All right, pins. You want?
Might as well use. I have to reconnect the ones that we had, so you might as well give me those ones first.
We can just use anything then.
Sure.
So these are I2C. I want to stay clear of some of these. So we have a GPIO 0. We could start here. So pin 11.
How does the count work? I forget.
So like here's 11, for example. That's inside.
Go to the one that you can actually see the pi. So I have a reference point. Or just show me where one is.
One is closest to the middle on the right hand side. So
closest to the middle on the opposite side of the USB.
The opposite side of the.
So right here. Represent the display.
So that should be 1.
So 11, 1, 3, 5, 7, 9, 11. Okay.
Yeah. And then 13 is GPIO pin 2.
This is going to be interesting. We're going to have...
What's easiest for you? Yeah.
What's this one? 13?
This is 13. It's another pin.
That's fine. Yeah.
15 is also good to go.
What's this one?
And we'll just use none of the PWM. We'll just
Okay.
use all
I agree.
software.
Then we can use them somewhere else.
Yeah, such a servo maybe.
So you want 11, 13, 15.
11, 13, 15, and 16 as well.
15. And 16. I kind of messed up a little bit. We're going to have to do some troubleshooting. It's my fault.
I don't know what happened.
I just, I shouldn't have disconnected them without really mapping it. Because
I
now
see.
we're going to have directional issues.
That's right. We'll figure it out.
Mine are fixed. Just I would have saved a lot of headache if I would have taken a picture or something.
Headache is great.
I probably have a picture. That's probably
It'd be good for everyone watching and see how we figure it out.
yeah, sure. Fair enough.
So 11, 13, 15, 16 as well.
Yeah.
And 18.
18.
Yeah.
Yeah.
And 22. So it's 18, then ground, then 22.
Yep. How many do I have?
How many do you need?
I need 2 more.
We're pretty needy. We're using all these pins. Oh my god. Can you use... I don't know what a lot of these different terms mean, and I'm trying to steer clear of them. Just use the...
Just GBO.
Yeah. So there's 36 and 37.
So what was the last one I used? 22?
Yep, correct.
So 24.
Or 26.
26, 28, 30, 32, 34, 36.
36.
46.
And 37 is your last.
37. Okay. Let's clean this up. This is gonna be interesting. It's gonna be tricky. I so what I was explaining to Vlad is that I way too quickly disconnected everything, and now I have no idea which connector is going to correspond to which direction for which motor. So I messed up, but that's okay.
That's all right. It's gonna be fun. We'll get to redo what we did before, and really try to understand it again.
Yeah. Yeah, that. Okay, so I'm gonna go. I'm just gonna go in order. So we're gonna go. Oh, I guess you should mark these down. Type this up or something.
Yep.
So I think my first pin was that's 1, 3, 5, 7, 9, 11. So 11 is mapping to let's call it
Yeah, 11.
11 is mapping to in one of the left motor driver. Now we will have it documented for next time.
Okay.
So 13 is mapping to in two of the left motor driver. 15 is mapping to in three of the left motor driver. And 16 is mapping to in four of the left.
18 next.
18. 18 is correct. 18 is in one of the right motor driver. 22. 22 is in two of the right motor driver.
Okay. 36.
36 is in three.
Cool. And 37.
37 is in four.
Cool. Oh my god. We need more pins? This is only left and right. Oh, I see. No. That's already two motors.
Yeah.
Okay, thank god. So that means in 1 and 2 is actually to one motor, in 3 and 4 is to another motor. So this is motor 1, 2, 3, 4.
Okay. Should be all mapped. Should be all wired. So you're gonna have to incorporate those in software as control points. We'll have to test each of the motors individually, make sure that forward is what we think forward is going to be each time. Well, I know I'm gonna be the man who's one with you. I would drive this RC car.
I'm just going to say what we got. So this is our...
I'll be right back. I gotta make a phone call.
Everything okay? Alright, so let me show you the code for now. So what we're trying to do is hook up those new pins. Now before we had the luxury of mapping two of the motors to a single set of pins, so we don't have that anymore. So there's gonna be a lot more code we need to have. So let's see what we are using. Motor 1, yeah. So here we only have two motors we set up because we know certain motors are already set up in pairs. So actually now we're gonna have 4 motors in total. Dun, dun, dun.
All right.
What was it before? They were opposites?
They were diagonally combined.
Diagonally. So if I have this one, so motor 1 and 2 were essentially the different diagonals. This was So there's this one here. Oh, so much work. So I might make a class just like this.
This is new information for me.
Yeah, so now that we have enough motors, managing them is irritating. So I want to make a class. I don't know how to do that, so I'm just going to look at the code that we have for the PlayStation 4 controller. So let's see here. Let me just look up Python class. No, let's create a class. So I want to look up how to create a class and specifically the constructor with examples. I like examples. Do not like videos though. Okay. I think the constructor's in it. Oh, it's underscore in it. But this one isn't that. Oh, I see you call it manually. Oh, so if this was underscore, it would have actually initialized automatically. Special function called, so one particular interest is the init underscore init underscore function. This special function creates is called whenever a new object of that class is instantiated. So that's what we want to use. So we actually want ours to look like this. Our motor. So I'll say this is the motor. Self is fine, and I'll show you what I want to do for the arguments in a moment. I'll just leave it there. So what does a motor represent? A motor is represented by these two pins. We have motor 3 pin. Yeah, so here we go. We have motor, essentially the first pin and the second pin. And so these two pins are used in pairs to represent essentially the forward-back direction, like the power and everything. Translation. So we need to go pin 1 and pin 2. And we'll make it required. I'll maybe do this. Okay. And pin 1 is equal to pin 1. Pin 2 is equal to pin 2. Now, I want to see what we did. I would like to take all this boilerplate and get rid of it. So when we have a pin, we first set this up. So we initialize the board. I probably don't want to do that a second time. So I'm just going to leave it at the top. So this part here is going to be copied. So this here. This is for the GPIO. We're setting up for a particular pin. This can pin 1, pin 2. We're setting those to be outputs. And then after we set it, we also have this control. So it creates a PWM instance with certain frequency. So in this case, frequency of 1000 using this pin. And then we start it with the required duty cycle. We're setting it to 0. So let's copy this one. So actually, notice there's a lot of duplicate code here already. So setup pin. I'll make this pin. It's pin 1. Pin. All right, so we can go now. We do this. See, now what we can do is we can make this more dry. Dry is do not repeat yourself. So, or ideally, yeah, or don't repeat yourself to be more accurate. So rather than having a bunch of the duplicate code, you see this is a lot of do. This is the same code 4 times over with a very small change. Same code 4 times over, very small change. Now we're able to say, here is the same code, and we're able to have one line that is the change. In this case, it's between pin 1 and pin 2. Awesome. That's more like it. That's what we like to see. Drier code. It's much easier to maintain. Let's see here. I'll clean this documentation up a little bit. And we're starting at 0. Good. So that's excellent. Boom, boom. Now this is the only difference. PWM, PWM object. So PWM. So let's actually return PWM, and we might actually want to store this. So PWM1 is equal to the response of this. So this allows us to use it later. 2. So given, actually we don't even need to remember these pins. So given pin 1 and pin 2, which is a way to represent a motor, we know every motor has those 2 pins coming in. We know we do the same thing. We set them up. By setting them up, we're saying this pin is a GPIO. It's of type output. Like a light is an output. It's not like an ultrasonic sensor or something like this where we take input. And then we're going to create this instance in Python, some object, something that we can, some reusable thing that we can pass around and call on. So let's say an instance might be, in this case, it's a particular pin that we can now execute on, or maybe it's a hockey player, and a hockey player can do different actions like run or jump or skate. And then we have, in this case, it's talking PWM, that's the instance. We're saving that as a variable. We're then calling a method. So in this case, the action we're calling is start, and we're passing that a value of 0. So it's duty cycle of 0, so it's no power. And then we're going to return from this setup pin that same instance, such that we can reuse it later. And how we're reusing it is we take it from this function, we pass it to this variable, so the instance of the motor can remember it. And so we have 2 of these. So we have the, and because we know the representation of the motor for going forward and backwards is using 2 pins of information. Great. So we actually got rid of a lot of this code here. So that's really helpful. And this is, so actually this part here, reusable variables for motor, this is actually what we just replaced. And so this was pin 1 right here, and this was pin 2 right here. And this is a motor 2 with pin 1 and pin 2. So we can actually rewrite these lines. And I think, how do they do? So you create it doing this, and then you call it. Okay. So we can now say motor 1 is equal to motor, and we pass in motor pin 1, motor pin 2, for example. Or actually, so this was actually 3 and this is 3 and 1. So this line of code is now replaced with this line, except we're also handling all of this code is all gone. So there's one line of code that does all of it, which is really nice. So we're gonna replace quite a bit. So actually, let's clean this up.
I wish I would have been here for that. I'll rewatch.
It's all right. Let's see. What pins did we have? Joystick testing. And now. So now we can go back to the notes that we just took. So this is a motor, this is another motor, this is another motor, and this is another motor. And they each have 2 pins, the first and the second. So in the first motor, it's in 1 and 2. The second, since it's on the same motor driver, the first pin is actually it's called in 3, and the second is in 4. So in this case, our first motor, that's left, said? Yeah. So we have left, right, front, back. So
actually, so the orientation of 11 and 13 is front. It would be front left, and then this would be. Yeah. So let me confirm that. I believe the top one will be front left. The second one will be back left, and then front right, back right. I think.
It's all right, and it's going to be very easy for us to change. So what we can actually do is say front left motor, and front left motor is pin 11 and pin 13. Boom. How readable is that? All right. Back left motor. And 15 and 16. And front and back again. This will be right. So we're going to go 18 and 22. 18, 22, and then finally 36 and 37. And we can always tweak these pins later anyway. So all of this code up to here, all of this code from line 25 to 51 is now line 54 to 57.
Shit.
So that's why I wanted to rewrite all this. It's because this is a lot of boilerplate, and actually this is better. No, sorry. This line 25 to 50. So that's 25 lines of code. Actually, that is only 2 motors worth. So it is only 2 lines, 54 to 55, is 25 lines of code down to 2 lines. So now to add a whole new motor, we only have to add 1 line. And every time we add a new motor, if we add another motor to this, we had 16 motors, something crazy. It's just 16 lines of code rather than 16 times,
Can I see your
12.
class how you did that?
Yeah, and that's just down here. So let me just open this up a little bit better. The class for motor is this, and the code we're replacing is this. So we know that for every pin, we need to set it to output. So we do that. For every pin, we have to create a PWM object that we can call actions on. So we create that object, we call start, and we also want to make sure that we can set it and reuse it for later. So we return it from the setup pin function that we also reuse, because within the motor, we're again duplicating code. So within the motor that is now already reducing amount of code, we also have a reusable function called setup pin that once again reduces the work you have to do to set up a motor. Because the setting up a pin is a duplicate piece. So now to set up a pin, one function call, and it does this twice. So it's quite a lot of savings. And then later on the road, we can say define something, move, and here's the angle, and we can define it and say PWM. I think everything is relative to self, but right, just set value. I can't remember what it's called, but yeah, like 99. So this is what we can do down the road. Is then everything's built in the motor class. So that right here, you can say back right motor move, 30 degrees. So that's all you have to do, and it already knows all the pin information, both pins information. It can even know its current values. It can make sure everything's set up. So it really simplifies what you're doing, because you could just say, I have a motor. I want to do that thing in common English, such as move or rotate or whatever, and it can abstract away all that you don't have to care about. So this is going to get a lot cleaner, especially as we're growing. Now we have 4 motors. We have to be very careful about how we're writing our code, because otherwise it's going to be 100 lines of code doing the same thing 4 times. And if we say, oh, I want to change a pin, we have to change it in all these different spots. Now we change it once. If we want to change the pin, we change it here. And it's very clear about what motor that's mapped to and how it's being changed. Just very readable. So
very impressive.
Yeah, so that was good. Nice clean touch up, an easy win. So I like it. We shall delete this. Very good. So we're setting up our motors. Excellent. I'm going to delete. Also, these are gone as well. We don't need this and this and this. All this is gone. So all we do is set it up, and we create a motor. Now I think this actually needs to be below. It needs to come later. I think it needs to come down here. And actually, matter of fact, we might even put that inside this PS4 controller. We have to think about how we want to do that. How we want the PlayStation to communicate with our car that drives, essentially. I have to think about that a little bit. Because before we had this global function, we had this move with angle, but no longer is that going to make a lot of sense, because we don't necessarily have these globally defined. But we'll get there. I'm going to move that move with angle is here, so I'm going to define our motors here, for example. And we'll reorganize this a little bit later. So now whenever we call it move with angle, we can call this move with speed, motor 2. So I think move with speed is something we're going to have to change. Move with speed took a motor, and the motor was that array. The array that represented the pins, the PWN instances. So like here, change duty cycle. So is going forward. So I think actually this right here, we're going to want to move this inside of our motor call. Over here. So now we can say move with speed. I don't have to pass it motor. it knows what it is itself, what motor it is. This one here is our PWM1. This one here is our PWM2. And you notice as we're going through, this code is becoming a little more readable because now it's an easier way, easier to reason language. Okay, cool. Got that. So move with speed. So down below, we originally were saying, hey, I'm going to give you this motor. But now what we can do, we'll replace these with something like this. I have to think about which are the pairs. So you said they're diagonal, so front left and back right would be the same.
Yep.
So back right, front left, and then front. And again, this is just for translation. This will all have to change when we start to do rotation, because rotation, they're all going to be independent. So right now, we should have the same functionality. We've set up our motors. We have 4 motors, not just the 2 we set up previously. When we now call on the motor instance itself. We're calling different methods like the move with speed. We don't have to pass in this object at the PWM instance anymore because the motor itself already knows internally what it has to do. So we can just say, hey, I need you to move with the speed. And if we do, it's going to look and say, oh, how do I do that for a motor? Well, given the speed, here's all the logic. I have my PWM pin 1, and that's already set up in my initialization up here. So I'm just going to take care of that. It takes care of that inside the motor instance. So that's for, and then these are diagonal. So we have the front left and the back right, and the front right and the back left. So this is mapping to what we had previously in hardware, but now in software. Went from 2 motors to 4 motors, but now they're all independently powered. And later on in the future, we could just say, hey, add some big random value, and it's only going to be on that one motor. We don't have to match them all. Yeah, so this should be it. I think we are done. So we're calling move with angle. We pass an angle. Move with angle just calls this, calls the motors. The motors are already defined. Yeah, that's it.
Awesome.
So in theory, this is good to go. Right. But it needs to be unplugged, right?
Yeah.
Okay, let me save these things first. Probably hates our guts for keep unplugging it.
Probably.
Yeah. Okay, I think it looks good to unplug.
Maybe I will just keep it on in the battery. I don't know. I don't really want to do that, but maybe we can do that. Just leave it plugged into the battery.
Yeah, maybe. Because we are going to be iterating pretty quickly.
Yeah, now that we're kind of pure software, these hardware fixes shouldn't be affected by the fact that it's plugged in.
Yeah.
From here on out. I wouldn't think. I've been wrong before. Interestingly enough, I know you don't believe me.
I don't think you've ever been wrong before.
No.
No, not ever.
Sounds about right.
I'll believe when I see it.
Mm.
Just don't look at our past streams, will you? I don't want anyone to prove me wrong that quickly.
Yeah, it's a low bar. Alright. You're testing it with...
So it should. So ideally, I just want it to drive straight. Actually, we'll just push it straight, see if it goes straight. Yep. Yeah, it should do exactly what it did before. And then we can start messing around with the other joystick, which will get very cool.
Yeah. Alright. Give it a shot. Should be ready to go. hopefully, when he pushes forward, all 4 of the wheels should go forward.
One positional argument, 2 were given. Give me a second.
Just let me know when you're going to press it again.
Might have just written a function wrong. Or the class, I mean. So class, you have different methods here. Controller, define, listen. I need Nacho Kitty. Nacho Kitty, help. I need an adult. So what is it saying? It is saying the setup pin, this right here. Does it say what line number? Line 15 is here. 46 is below. So line 15 here. So this takes 1 positional argument and 2 are given. Why don't you give me one thing?
Like I said, takes 2 and 1 is given.
It takes 1 positional but 2 are given. I wonder if it always has self. Oh, I think that's what it was. I had to add self. So all Python methods have self when they're in a class. Cool. Okay, that's pretty weird. All right. Ready to go?
Ready to go.
Motor object is not callable. Okay. Give me a second. So where did this come from? All right, well, let's just Google it. Oh, actually, I shouldn't have done that.
Shouldn't have done that.
Usually get rid of the parts that are specific to you. So in this case, the thing being called motor. Class A defines self today and something. Oh, interesting.
So for anybody that's interested, Glavin is certainly
Not a Python wizard.
not what I was going to say. Certainly the expert out of the 2 of us when it comes to software. I watch him do this work, and I'm astounded at how quickly he can get through a lot of problems that would have taken me hours, if not days.
Let's hope we can get by this one before the day's out. I'm pretty sure I just built the class wrong. That's what I get for being my first time in Python in a while. So motor, if we look at here, line 134, listen, so line 65 is probably where we need to be looking. So line 65. Oh,
What'd you do?
oh my god, what a doofus. All right, so everyone, here is an experiment, or here's a pop quiz. So look at this code. So if you look in the error, it got down to line 65. That means this code worked. This code failed. Do you see any difference between the highlighted code in blue and the other code below in terms of how we are calling the motor to, in this case, set its speed? Do you see it?
Yeah, you're missing the dot with the speed.
Yeah, it doesn't call a function. It's just
It's
like, hey motor, here's a speed. It's like, what do you want me to do with it? Like, I don't know. So we have to call the action. We have to call the function. Boom, boom, done. Beautiful. All right.
All right.
Don't try this at home, kids. All right.
Let's do it.
Actually, let me crank this down. I think we're at 100, aren't we? You say it's fine. I'm going to explode everything. I think it's this value.
They're doing crazy things. What is it trying to do?
I don't know.
Drive forward. Drive
So
forward.
yeah. So that's forward. At least we know it rotates. Here, 1 sec. Let me.
Wait. So that means that every second wheel is reversed. Okay. So which wheels are correct? The back right wheel is correct. Do it again. Go forward.
Can you move it a little front?
Back. The right side. Both of the right side wheels are correct. Both the left side wheels are reversed.
Are reversed?
Yeah. So the left side, the front left and back left have to be reversed. They're pins.
So 13 and 11. 16, 15.
That should do it. It's also nice that the code is that's a huge change.
Yeah, now you're talking.
Except why did that wheel die?
I don't think it's tight. Oh wait, no. Well, that's weird. Back left, front left. Let's just look down here. Front left. So front right. Back left. I don't know.
Do it again. So front works, back doesn't. Why doesn't that hit?
Are one of the pins not connected properly?
Yeah. Yeah, maybe.
It only drives front forward.
Just that one wheel. Okay, so that's the front left wheel? Or
Yeah.
which wheel? Do it again. I want to see which wheel. Go backwards. I forget which wheel it was. So back right wheel is incorrect?
Yeah. I know I was able to see this. You
Oh, sorry about that. Yeah, so here, do it here. That's fine. So in reverse, only 3 of the wheels worked, and that's because one of the 2 pins for the back right wheel isn't connected to something that's getting voltage. So we're going to try changing the pin to a different GPIO pin for now.
does that mean you have to?
Can you give me a new GPIO pin? And then I'll map a new GPIO.
Is it safe for you to be moving the pins around?
Yeah. Maybe not.
How do we? This one need that freaking switch. The problem is I don't want the pie to keep going down.
No.
So can we make a temporary switch just to not fry your hands?
Oh, I'll be fine. It's only 5 volts.
So the pin you want back right?
What's back right currently, Matt?
36 and 37.
36. So give me 2 different ones.
36 and 37 are here. Do you know what these terms do? Like this is SPI. I guess we can use some of the SPI pins.
I'd prefer not to use SPI. They'll come up.
So that's also. What about GP clock? GPCL-K1.
Yeah, we could probably use that.
29 and 31.
Okay. 40, 38, 36, 34, 32. I forget how the counting works.
Odds on the left. And then
Our first one's 11, correct?
correct.
The lowest number's 11.
Yeah, you can count backwards. So 39 on the left is the ground. So 39, 37, 35, 33. So you want 31 and 29.
Okay. Okay. So let's take this one. So 39, 38.
Should we use the multimeter to test the voltage on those pins we're getting? That'd probably be a good logical step before switching pins.
I'm kind of afraid of using the multimeter on these pins now that I've fried. I think I fried the other board because it's a metal object between two pins.
Okay.
It's very small.
So you could just touch ground.
I could touch ground.
Okay.
That's my fear. Yeah.
Yeah, like we did before. We had like the multimeter between two pins.
Yeah.
Yeah,
That's probably what we fried it with. Either that or putting it on a metal plate.
yeah, let's not do that.
37.
It's weird the tester can actually break the. Yeah. Gosh.
31.
Oh, sorry, 1 sec.
It scared the crap out of me.
That scared the crap out of me too. Oh man, I killed the script. You must be in power. Did you plug it into something?
I did.
What did you plug it into?
I plugged it into 31, I thought. 20, 39, 37, 35, 33, 31.
I don't know what that does. Maybe that's. Maybe it has some. It's this thing right here. GPCL. I don't know what that means. GP.
General purpose clock, I would imagine.
So maybe it's always giving current?
Kind of does it.
I don't know what it does. General purpose clock. Output fixed frequency with outgoing software.
It's just a counter. Oh, man.
Okay. Try 29.
Okay, so I have my 2 pins in my hand.
Because I turned it off since.
Okay, so I have 40, 38, 36, 32, 30, 39, 37, 35, 33, 31, 29. That goes forward.
So it's power. Depending on what pin you're putting to.
29 and 31 are both giving me power.
I guess. That's weird. Okay.
Give me 2 other pins. It's fine. Give me, even if it's SPC, like
SPI.
or anything.
Try 23.
39, 37, 35, 33, 31, 29, 27, 25, 23?
Yeah.
Okay, 23, give me another one.
21.
Do we have a 22 already?
Yes.
Okay, good. Just making sure I'm the right one. Okay, give that a shot. Remap those.
Which is which? Which is in one? So 21 and 23.
In one is 23 is in 2. Or 23 is in 3. And then 21 is in 4.
Okay, perfect. Oh, I didn't ask. Are you ready?
Ready.
Okay. Here, I'm going to put it on hardware so everyone can see it.
Sure.
Okay, going forward. Alright, going backwards.
Cool. Thanks. Nice. Wait, what?
Let's go sideways.
Oh, okay. I was very confused. So let's put it on the floor. Make sure it's doing what we expect. I'll get the camera. Is that what we expect? Not really. It's the opposite of what we expect. Go forward and reverse. Okay, so the pairings are opposite. That's why. So you have the right and the left paired instead of the diagonal. Like you have both the right side paired and both the left side paired. I think. No.
Yeah, give me a sec.
It's a pairing issue, but I don't know. I guess I can't really think of how.
Yeah, so we just want to make sure. I'll just flip the backs maybe. So if I go left.
Should put a minimum. Like,
I think it doesn't have enough juice too. It's like seems to be.
I disagree. I disagree because the reason it looks so funny is because these two are being the dead wheels on a translation.
Yeah. Okay. Well, I can just try it quickly.
Instead of these two being the dead wheels, kind of thing.
So if I switch around the front left, back left, front, right.
Yeah, you have both the front wheels paired and both the back wheels paired instead of.
Okay.
If that makes sense.
So then front wheels pairs. So I should just switch what?
You should switch. You should make it so that the front. So right now you have it so that.
Can you hold it up?
What's that doing? Yeah. So these two wheels are doing the exact same thing as each other. These two.
So if we switch the front and back for one side.
Yeah.
Okay. So then
Yeah,
this
exactly.
back left, I will switch with the.
Yeah, that makes sense.
That's why I wanted to have it nice like this, because then it's gonna be.
Yeah.
So this
that's
is
a good call.
16,
Very good call.
15, 15.
Somebody message it.
I can't see it. Can
Make
hold
you get beers. Yeah.
One day.
That's the dream.
Freaking. All right. Good.
Here, let me show off what it's doing. All right. Give it a little control there. That's beautiful. Alright, so our next. Alright, killed there, just the battery just came detached. It should
Oh really?
tape. It's just not taped. It's kind of riding against the ground.
Okay.
We'll fix that.
Sweet, sweet, sweet.
Alright, there's another success. Took a little longer to get the success than expected. Not that. That wasn't that bad.
That wasn't bad.
And I think you cleaning up the code saved us a lot of time there.
Yeah, it's gonna be really nice to work with after this, and it's only gonna get better.
I'm actually going to put a piece of Velcro on the wires. No, that seems like a bad idea.
I think getting beers for everyone will be a good goal. This can actually, one thing that really impressed me about this particular motors and chassis is it can carry 10 kilograms. So I think up to 10 kilograms of beer we could potentially put on its back. Right? I'm very excited to test that.
How heavy is a can of beer? Like a quarter pound?
But I don't know. That's how heavy beer. Yeah, so it's 0.78 pounds. So 10 kilograms to pounds, of course, like 2.2 or something. So 22 divided by. Wait, sorry, how am I doing this?
So it can carry a 12 pack?
It can carry. Is that right? 28?
That can't be right.
22 pounds, and beer is less than 1 pound.
So this, if we build a good mounting structure, this could theoretically carry a 2-4.
Yes. So yeah, there's our goals. Life goals right there.
Drink to celebrate. Get it to carry as beer to celebrate.
Pretty much.
All right, so that's set up. Car is set up. Now we just need to consider rotations.
Yep.
Oh, John, this sucks.
I'll let you figure that out. Okay. So rotations. That was part 3 and 4. Same idea with the coordinate system. Now the thing about rotations is, it doesn't really make sense what we were doing. So before we had before, if you're taking your joystick, you have your left, right, front, back, your up and down. You have the speed, like the magnitude of that. So if you hold it all the way out, or if you hold it like halfway, so we have two outputs essentially. We have the angle, so the angle around the circle that we're rotating this, and we have how severely we're putting it. Is it slightly off from the dead center? It's a little bit off. We have the same math we could do for the right joystick, but what does that mean in terms of rotation? So rotation, we're spinning it. So we're spinning it in direction. So direction is still pertinent, and we'll probably have the speed of that rotation as well. But what would be intuitive?
So yeah, we have two kind of choices the way I see it for the right joystick. One choice is we have to rotate the joystick to rotate the car. The other choice is similar to how you play Call of Duty, which is hold the joystick to the right and it will continuously rotate.
And I feel like that's probably going to be what we want, right? So actually,
So that means we don't need vertical at all.
yeah, that's exactly what I was going to suggest. Yeah. So then it's just simply give me the horizontal -1 to +1, and then map that to a maximum rotation speed.
Yeah.
And then that's it.
Yeah.
All right. Cool. Cool. I'm excited about this. So move with angle. So first things first, let's get our joystick values.
First things first on the realist.
Yo. So we have a right joystick.
You don't have a micro USB that I could cut in half, do you?
Do you mind?
Okay. Not good enough.
Not good enough. So the right joystick, which is going to be used for some of those translation values, it's actually 3 and 4 in this array that we receive. Raw motion. So actually, we don't even need any of this. So I gotta think about what I want this thing to do. So I don't need this. Move angle. Move angle. I'm just gonna clean up some of this code here. So if it's at 0, we can't do any arctan thing. We actually don't need arctan for any of the stuff that we're doing here. We don't even need Y. We actually only need the x-axis. So, so this is raw move angle. Actually, that's probably still correct. It's still the move angle. So we're final move angle, and then we have I think something like a rotational velocity, right? Like it's rotating this way, and how fast is it, and what direction is it?
So what we know is all 4 wheels have to be going in the same direction to rotate.
Yeah.
Like
well, the
Not the same direction.
right would be going forward. Let's say we want to go counterclockwise. The right's going forward. The left's going.
yeah, you're right.
Yeah. So whereas right now translation is diagonals.
Yeah.
But to rotate, we actually want them to be lined up. So it's like tank treads.
Yeah.
And then we're merging these two strategies together so we can translate and rotate at the same time. So maybe we could just add spinning right now just to test it. We'll just add it to the right spot. Maybe that's a good spot to test. So I'll just do that right now. So we'll put some fake value in here.
Big value. Why don't you just have it with the amount of joystick?
I could. I have to think about like what I want it to be. So if we have it coming from the joystick, we have -1, +1.
Mm-hmm.
This we want to rotate left, so that would be all stuff on the left side.
If it's rotating
Yeah.
left
Why?
side has to be going backward.
Actually, that's a good point. It doesn't like left and right. Is left counterclockwise and right clockwise? Because that's really what we're saying.
If you're rotating left, the wheels have to go counterclockwise. Yeah.
Yeah.
Yeah, counterclockwise.
So left equals counterclockwise. Okay, so we could do that with the wheel angle, speed coefficient is passed in. We'll have this rotational velocity.
Is it counterclockwise or clockwise?
I don't know. So,
Just trying to picture it. Sorry.
So if it's dead center, it's 0.
Yep.
So it's going to be something that's additive. So 0 times the maximum. So we'll set some max. And then, so everything on the left side we want to be the same. Everything on the right side we want to be the same. So we just do this. So on the left, we'll just pick it. We'll pick it. So left side will go positive. Right side will go negative, and we'll fix it based off how it feels. Oh, I guess I mixed these orders up. So front left, right, back left, right.
Yeah, clockwise will spin left.
So front. Actually, would this be nice? We want left to be positive. We'll just say so they're consistent.
I think it's left will be clockwise.
Okay, cool. Oh God. So this should be -1 to 1 is what this x-axis is going to give us. I think we're going to have to multiply that by something, though. We'll multiply that by 30 or something. It's going to get too big.
Why do you say it's additive?
It's additive because so we have all the motions we need to get to moving, and then we're also going to add on top of that the rotations. So like we need to spin this way to move, all relative to each other, and then also there's another force. So we're just going to add the both forces together. And we'll have to figure out like which, intuitively which angles. The problem though is if it's additive, we also have to normalize them, because if we wanted to spin while moving, we only have a max 100%. So we actually have to say if you're spinning, we have to. Yeah, that's interesting actually. I don't know if I'm doing that right now. Wheel speed coefficient. I think we have to add this earlier. So we already have a normalization. The problem is we have to do this earlier. Wheel speed. All right, we might break this thing, but that'll be fun. Speed. If it's going forward, I think the big thing is we can never pass in a value. The max, so we want the minimum. As long as we do this, then it should at least correct itself. So we can't ever go above 100. And then we'll correct this. So I think that there's a bug in here. I'm fairly certain. And then our solution here is too simplistic. So there's a couple things, but at the very least, we should be able to get inputs and it will roughly rotate.
Okay.
All right. Let's give it a shot. Won't be perfect, but we'll do a thing.
It will do the thing.
We'll do a thing.
All right. That's it.
I'm a little scared. Oh, you camera?
I guess. Yeah. I guess. You want to see as bad as I do, don't you?
Oh, yeah, watch the light there as well. You can like this thing is long, so you should be able to just like. It's okay. Okay. Good enough. All right, I shall start it, and let's pray that it doesn't run away from us. It started. So this is just translation. Oh, actually, translation's reversed right now. Front. I go forward, backwards, left. So that's off. Okay. How's that?
Is that what we expect?
Yep.
To an extent.
Yeah, what?
How intuitive is the control, other than the fact that part of it's backward?
It would be great if it wasn't flipped around and hurting my foot.
Well,
Yeah, if the left and right were there, I think it's pretty intuitive.
Alright, flip them now then.
Yeah.
So
What do we
so
do
you have
this
to
then?
pair. So what have you done? What have we done? What have we done wrong? How are they?
Left and right are flipped. Was that what it was?
I guess so. Yeah. Yeah. Left and right are flipped. So change right wheel to left wheel.
For all of them? Wait, what?
Change the.
Yeah, what was it? We fixed this before. Love the moon, really cool. Yeah, I'm super pumped. This is looking great. What did we do last time? We had the same problem. So.
Okay, so your translation, I fixed it from the hardware side.
I think it is a hardware problem. No,
Well-
I can fix it. It's a hardware problem. So, like,
Yeah, I just need to think of what the problem is. So the left. So what's happening is the right two wheels are spinning in the opposite direction that they should be spinning, right? But only for translation.
maybe, yeah.
Spinning
So,
in the correct. Yeah. So
so all the right and the lefts could be switched?
that doesn't make sense. That
All right, so, yeah, maybe.
That doesn't make sense. Think about this a little harder than that. Because you can't switch them, because I have them physically wired on the left side and the right side. They can't be that long.
Well, probably my math is just off then, but.
Your math is a negative. Negative 21. Does that make sense? Because if we flip their pins, then it'll be forward when it's supposed to be reverse and reverse when it's supposed to be forward. That's not good. But if we switch like the left wheels to the right wheels, then technically it's not wired correctly. Is that what you're expecting?
All right, it's fixed. All right. Yeah. What I did was I switched all the motors. Like the left was right and right was left.
I don't think that's possible because, like, I think
Yeah, because of, yeah,
unfortunately we're wired incorrectly.
I probably. Yeah, there's probably the negative somewhere.
Because that's a solution. It's just
It's doing the mirror of what we expected to be doing. So you're sure these are?
so pin.
Like I gotta just check one of them.
Yeah, I'll check one of them. So pin 11, 2, 1, 1, 3, 5, 7, 9, 11. Pin 11.
Remember, we did reverse a few of them.
Pin 11 goes to second. Pin 11 goes to in one of the left wheels.
In one, not in three.
In one. Pin 11.
Well, there's a problem. It's currently going in. It's currently going in three. Is how I had it mapped. Or in two.
Oh, jeez.
So like we're just flipped.
We're flipped. So
Yeah.
that's supposed to be
But that's fine. That's probably why.
in one. Yeah.
That's why flipping it helped. Is because we needed certain things to be backwards when they should be forwards.
Yeah.
Yeah. So that's why flipping them around because we just
I know what happened. I didn't I was looking at the two motor drivers sitting beside each other, and I didn't. When I was connecting the second one, I didn't look at it again. Is it correct now?
I should have changed the rotation here because it's not intuitive. But yeah, that's pretty good.
Yeah. What happened was when I was putting in one motor driver, I did the mirror instead of the same without reading the numbers. So
It's okay.
That's on me.
That's okay. Well, this is good. Well, that's why we wanted to test it. Is it'll just tell us. I wanted to buff up the rotational speed though. Give me a sec. I want to give this a lot more leeway. Or I just break it. Dude, you gotta try this.
Dude. So did you fix it so that
Give it a shot. See what you feel.
what do you think, Luger? Pretty great. This is pretty amazing.
Yeah, man. This isn't even full power yet. Is it maybe 60? Is it falling apart again?
Yeah.
Ah, there it is. These little pieces are falling off.
I saw a slight glimmer. I saw like a little shine out of the corner of my eye. The light catching the piece of metal as it flew off the back of the car.
Oh god. Alright, so that's the second time we broke the car. It is, bro, this is 60. This is not 100. It's breaking itself right now. But how do you feel intuitive-wise?
That's pretty crisp. That's pretty amazing. So driving functionality's done.
Good to go.
It's just done.
It's just done.
That's amazing.
And I think we could do better. Like, to me, I think there's already 2 areas we can improve upon. But
What do you want to?
so like right now we're adding both together, but the normalization happens first, and then we add them. So if you were to do something that made, let's say you let's say you went full right while rotating or something, it could maybe add up to be over 100. But then what happens is later down the line we cap it at 100.
Yeah.
So then overall it is the complete solution is correct.
Okay. Did you change it back such that because you flipped it so that the left wheel corresponded to the right wheel? Is that still how it's set up or no?
Yeah.
So we should fix that just for readability of the code, because when you look at the hardware and the software and you see that they're 2 opposite systems, it's going to be confusing in the future.
Yeah, a little bit. You can take a look.
It doesn't make a difference. What we'll have to do.
It's still nice in here. Like the key thing is, are they diagonal and then what the left's and right? So like they're doing it. It's just that the name is the opposite of what it would be if you actually look at the hardware.
They're mapped diagonally. Oppositely.
Yeah. So it's a little. Yeah, it could be corrected. So I think that's another good thing to correct. But yeah, overall, it drives.
It drives. Hell yeah. That's great. I'm gonna fix the car now.
Falling apart. Oh my gosh. That's sweet. That was sweet. Alright, I'm gonna turn it off before we actually hit the controller and it just has to like.
Sure.
Does this seem? Oh, it kind of does. There we go.
I can shim to the camera.
If you could, if you could just read out the mapping scan, we could just reprogram them.
Sure.
Everyone read the text in here. I hope so. Oh yeah, it's legible. Okay, good. Oh, well, I'm glad that worked. Okay, so remapping the pins, make sure they're accurate to the hardware, and make sure the software lines up so all the naming is correct. Making sure the normalization is done at the right step, such that we don't max it out and the balance isn't correct. It's working, wireless working. It seems to be pretty fast.
Okay, I'll read out the mappings.
Okay, I'm gonna go up here.
She's like.
Okay, hit me.
So left motor driver in one.
Front left? Or yeah, okay.
I don't really know.
Can we figure that out actually first? If you can just find out what in one of both motor drivers is mapped to, that would help.
Okay. What I'll do is I'll just unplug them and see which wheel doesn't work. If you want to run the
We
script.
can do that. Yeah. Is that safe for you? That I don't know.
Yeah, it's fine.
Okay. Promise?
Safe for me.
Okay.
Safe for the car.
Okay. Alright. What do you want to do here?
Promise.
Drive straight?
Drive straight. Okay, so in one and in two. Okay, we can stop that.
Alright. In one, in two.
In one and in two correspond to the back left wheel.
Oh, I see. We had a front left here.
Okay.
What pin is that?
In one is 11
And 13's the other?
and no. Sorry. Yes, 13's the other. Yeah, I understand why. I forgot that it's mirrored, so any assumptions that we made, the assumption would be the mirror.
So 11 is in one, 13's in two.
Yeah.
Okay.
So in three should be 15.
Yep.
In four.
16.
In four should be 16.
And is that front left?
That's front left.
That's why. Okay. So actually, we just did in software what we're now learning. So like, I think actually, if I look at front left dive is 18. So that's okay. So I still have some mappings that are a little bit off, but I'm sure we can clean it up.
Do you want me to read off the other side too?
Yeah, that'd be good. At least one of them.
Yeah. Okay. So so that's 16. So 17. Pin 17.
Do we
or
have
18? 18. 18 goes to in one.
In one
In one.
on front right. Or something.
In one would be. What was in one on the other one?
Back left.
Back left. Yeah, so this would be front right. That's correct.
That's good.
So that means they're all right. That's all correct.
Okay.
That's why it was mirrored. It's mirrored because when I was looking at the car, I forgot that these are mirroring each other physically. So I had everything was reversed and I didn't account for that.
That's all right. Sweet, sweet, sweet. We're almost there.
Let's test again. Make sure that fixes everything.
Yeah.
Just that it's still.
So front left, front right, back left, back right. So front, front left.
That's an interesting view.
Not
Not bad. Staring at my pants.
Yeah. Back left. Back left is the 11 to 13. Front right. Two. 13. 36. 37. Okay. Can I test it again?
Yeah, I'm gonna get you to drive it. I'm gonna take a video of it. I know that we have active video going, but personal video. How's that? Oh, that's me again. How's that view in the car on the screen?
That's wrong.
That's wrong.
Forward.
What do you mean forward?
So that doesn't work at all. So that one's broken.
Oh man. Okay.
Which one was it? That's back. That's back right. 36, 37.
36, 37. That we changed those.
Oh.
We changed those to 21, 23.
That would make sense. Can you check? It's 21 in 3.
I'll try. So that's 11, 13, 15. 21 is in 4.
So then 23 is in 3.
23 is in 3. Oh man, I got those mappings so wrong.
It's okay.
I read them all.
Okay, we're gonna run it.
Step forward.
What's that? This is rotate left.
What?
Oh God. What?
What in the hell?
What? So forward. So it's not going diagonally.
Wheels aren't paired properly.
How did I? Maybe I solved it wrong.
You have the wrong 2 wheels paired.
Oh.
I think you had the sides paired instead of the diagonal. Is that right?
Yeah.
That's forward. I don't. It didn't look really forward to me.
Interesting. So it looks like it should work.
Did you change it?
So here, so left. So left, front left should match with back right. And it is. Front right matches with back left. And it is. And I should be confused. And I am. Okay. What? What? I don't. It'd be okay if it went backwards and went forwards, but I don't notice.
Can you run it again? Let me see the controller. While you're doing this. I'm just trying to think.
Well, like, we can definitely fix it. Like, that's easy. It's just like I don't understand the fix. So like it literally means our that's left, isn't it?
So if I'm pushing right, that should be rotating counterclockwise, which means the left wheel should be going forward. So the left, or sorry, that means that the, like if I'm doing this, I would expect it to rotate this way.
Yeah. Well, it's simple to see what it's doing wrong, right? Like, so you hold
Well,
forward.
I just want to see what's it. So this should be going. This is correct.
They're all forward.
This is reversed.
This is also forward.
Yeah, but that
Yeah, but do the easy one. Just if you just go all forward. So this is back,
Oh, yeah, I guess good point. This is forward. This is forward. This is back. So the diagonal needs to be switched.
So like I can fix this off in like 2 seconds. The problem is,
It's not mapped properly.
yeah. Then why? And we literally just mapped it. So it must have. Could we possibly have read it wrong? Again.
I mean,
Reading is hard.
I've been wrong before. Back to that comment. Okay.
So what do I want? I want to mix up the.
Well, on the right. So which side was incorrect? Because you can just flip the sides pins, input pins, and that's all you need to change.
Well, they're all incorrect.
No.
They're.
Do you have in one, or do you have in four on the right side as back right? In four is back right.
Yep.
So if I go forward,
In 4 maps 21.
so if you flip both of these on the inputs,
On left.
yeah, the front and back left, flip their input pins. I know we did that already, but we've made some changes since. So, is that on video? That's reversed.
Rotation.
Everything's reversed now. Everything's back to being reversed. Oh, so.
Try
What
this
the
one.
heck?
That works?
Yeah.
Yeah. So what are the differences we have? So what actually works? Front left, 1822. Back left, 2321. So what's different here? Everything. This is this is what we wrote down. This is after I switched some of the left ones. This is what actually works.
18 and 22. So it's like there's a negative somewhere.
Like there's a negative somewhere, or one missing.
Or one missing.
Okay, then
I'm gonna go with no on that one. Yeah. It's gonna tear itself apart. That's an interesting one. Forward, backward, left, right. And the rotation's reversed. It's too bad because it is. Yeah. I think this is. I know this sucks because it's like it's not even a true problem. What is a true problem?
Can you pass the controller?
Sure.
That's weird.
They're all weird.
It's diagonal, right? So front left should match with the back right, which it does. All right. Well,
Go back to the working one.
a little bit. Don't really know why, but like we can just look at it and see it.
This is my first thing.
So in terms of what's flipped, the motors are totally flipped around. So the let me match these guys up. So the front left actually maps to the front right. The back left, so like these are flipped. Those values are actually flipped as well.
Is everything flipped?
There's a lot that's flipped. There's quite a bit. Except for this back left one is the same as this back right. So 23, then 21. This one is 13 and 11. So we identified that as a bug. How far off is this one? I think this right here is is the closest we got. So okay, so at least it's fluid.
That one works, but everything's the opposite direction.
All right, so let's see what's wrong with this. So front left, and in the working case is 1822, but that's actually right. 16, 15, 13, 11, 20. So all of these values are, so the one here that is 16, 15, 15. So we had to reverse 15, 16, and 11, 13. Was that because the hardware was the opposite of what we expected? 23, 11 was in one. Yeah, why did we switch these?
I don't remember. Probably.
Okay, well, we have one that works. We'll have to take a look. It's something, it's something up there. But We gotta read it. That's the nice thing having a wire. Having the wires all open. Like
It works there. I'm gonna take a video of it.
Yeah, I want to correct the normalization because I think it'll actually drive better.
Sure.
I think it's drifting too much. Speed coefficient. Where the fuck did you come from?
I'm just gonna check on all the pieces, make sure everything's still together. Woohoo! It was about to fall apart. Oh my god, we were about to lose a whole wheel.
What's up with it? How do we get it to not fall apart again?
I need to get a. I'm trying to tighten it, but it's tough. It's just tough. It's really tight spots to kind of get a good grip on the nut.
Yeah.
Okay.
So working car with translation and rotation. I'm just committing it to Git.
What are you fun about it?
Wants me to configure the identity. I don't care. Do we have an email right now?
An email thing?
Yeah.
Yeah.
Is it behind the scenes engineering or eng
That's good. No, engineering.
at gmail.com?
Yeah. What are you doing there?
It wouldn't let me commit until we had a name. There we go. All right, I just set up Git. So now we can actually save and be like, make checkpoints. Okay. Looking pretty good. So what I want to be able to do is rotate. So if I rotate, so this function here that has normalization, I want that normalization to happen on what now? Speed coefficient. So it's normalizing it to 1 first, and then if it is coefficient is less, I want to make it 1. Oh man, Lucas, is it really wrecked up?
Yeah. We basically almost lost an entire motor.
Oh my God. Should I zoom in on you? I could go videotape what you're doing.
No, it's okay. I'm just tightening some nuts. It's not worth watching.
Cool.
It's really not that exciting.
Okay.
Almost done.
So right now we have a problem in our code. Not a big problem, but I think it's inefficiency. So when we're saying move with angle, we were given a wheel angle. We have the speed. So that's essentially if you're on the joystick and you move it all the way up, you get 100% of the speed. But if you move it maybe half, you get 50%. So that's that speed coefficient. And the third thing there is the rotational velocity. So that's the other joystick, the rotation joystick. And we just go right and left. And that allows us to spin it clockwise and counterclockwise. So the issue is when we add this rotational velocity. So we add it here at the end after normalization. So what that means is we have every wheel can turn at max 100%. But because we're actually changing the relative rotation of each of these wheels, to make it work as a complete system, we're not going to have these wheels always at 100. They're going to be dialed back such that the ratio is going to work out, that the whole system does what we want relatively. And that happens because of this normalization coefficient. So it looks over them and says, oh, I see that, I need to rotate this one by 50, this one by 50, this one by 50. And we can normalize them all by dividing by 50. So we get them essentially a 0 to 1 range. So now it's normalized, it's 0 to 1. And then we multiply by this coefficient. And that's 0 to 100%. So 100% being our maximum speed that the motor could ever possibly do from a hardware level. So in software, we change the range from 0 to 1, and then we scale it up to 100. But after we scale it up to 100, we add this next thing, which is our rotational velocity. So in certain cases, we might already have this motor maxed out to 100%. And then we say, oh, also motor, I want you to add a little bit more because you need to do this thing such that we can spin and rotate the whole body. And it doesn't make sense. So that motor that's already at 100 is now actually at 110. And 110 is just going to be set down to 100. It can't go above 100. So you'll actually only get 100 out of it. But these other wheels are expecting 110% out of that one. So now, as a complete system, relatively, they're not turning at the right rate. So what we have to do is dial it back. So the maximum value is 100, and that 100% incorporates this rotational velocity. Yeah, so that's essentially it. So let us see here. Rotational speed. Probably quite a lot, actually, we're going to have to change here. So I'm just going to save this as something to remember above. I like to just do this temporarily because then I can go up and reference the old code. I'll just copy paste a whole block, and then I can look up and say, okay, what did it previously look like? What does it look like now? So in this case, we don't need to look at the angles anymore. So I'm going to clean this thing up. So we want to add rotation to each of these. Let's see now. So wheel 1, wheel 2 speed. So that's it. Let's change this from wheel 1. Let's just wheel pair 1 to be more accurate. Actually, I'm going to because these are pairs of wheels. And then now we can do speed on an individual level. So front left speed is equal to this wheel 1 speed in this case minus rotation. And we could do the same for the rest of them. So front right, back left, and back right. So in this case, we want this to match. And we have negative, plus, and we can adapt these later. The important part is that we have this value here, which represents this relative speed that we want to provide. Now, if it's, I think this is actually still going to cause a bug. because we don't want them to be, if we're saying max, what's the maximum value if they're all negative? Let's say we go in reverse and they're all going to be negative. If they're all let me see. Sorry. If they're all going to be negative, what's the maximum value of negative? Notice we get a negative number back. So maybe this is going to be fine. The whole point is we want to normalize this to be between 0, normalize between 0 and 1, inclusive. So if we have all these values, let's see here. So Python max pass array. I'm going to do that. Cool. So if you pass an array into max as the first argument, it will just get you the max of the whole array. Do I even need to do that? Maybe not. Oh, I see. So we do absolute value it. All right, something cool we're gonna look up. List comprehensions. I want to do a map. So what I want to do is to every value, apply absolute value and then pass it into max. So sum for this and this. So this is actually what we want to do. So we want to create so we're going to absolute value the speed for speed in my list of speeds. So all speeds is equal to this plus this. Does it have a webcam? Yes, the car does have a webcam. Probably next session we'll be able to dive into that because that's going to be a lot of fun. So we can actually make it drive itself and recognize objects and navigate around. So now we can replace this here. So rather than just having two of them, two of the speeds, we're going to apply absolute value to every speed in all the speeds, which is the array of each of these, or a list essentially. So all the possible speeds for all the possible motors, we're going to see the maximum value, and then we're going to normalize based off of that. Do we need the minimum for some reason? I feel like we might.
The minimum would be, we can test around and find the minimum turn on. You might as well just not give less than the minimum turn on. So it'd be like,
Yeah.
you know, try and hard code a 30, see if it turns on, hard code a 20, see if it turns
Well,
on.
I mean, right now I'm normalizing it between something and 1. I guess it's between 0 and 1.
Mm-hmm.
It won't be greater than that.
Actually, you know what? I think that's fine. I don't think we need to have a minimum other than 0.
Yeah, so I think this is accurate. Okay, so now we have this normalization coefficient. If it is less than 0, less than equal to, so I think this is just if it's negative or 0. If it's 0, below, down here we divide by it. So we can't have it 0 because divide by 0 is just, you're not allowed to do that. Okay, so this speed here, just velocity, I think this needs to be changed. So this rotational velocity currently is already between 0 and, it's between -1 and 1. So that actually, we may want to clamp it. How do we do that? Actually, maybe that's just fine. Let's just leave it. Because if let's say the motor was going to be 100%, it was going to be 1. It was full forward, that's what it was going to do. And now we're saying, based on the rotation, I actually need you to go -1, so full backwards.
Mm-hmm.
The end result is 0.
Mm-hmm.
So, and if it's 0, then it doesn't matter. So I think this is okay just to do it what we're doing. And I guess we'll find out when it comes out. So we have this, subtracted it, or added it. It's great. We're going to normalize them all. Great. And this speed here, we're actually going to switch them around. So front speed is going to be this guy. Front right here, back left here, right here. And then this can go away, this rotational side, because we've done it ahead of time and incorporated it into the normalization. And then when we're applying the speed coefficient, which is, so all these rotational pieces, those were all relative between 0 and 1. Now let's scale up to the full range of the motors. And in our case, we have, we can go to 100%. We actually have been scaling it down to 60 because even at 60, the whole car is falling apart, right? So we're going to keep it pretty low, so at 60 probably, but that's what the speed coefficient does. We're keeping it 60%, the full power that the whole car can do on a per motor basis. So this should be it. In theory, this should account for both translation and rotation, and it does them before normalization, such that the whole scale of the system will between 0 and 100%, or in our case 60% of the motor force. So it won't go higher than we want, and it won't clamp at the top. Where if you had a motor and we said, I need you to go 100%, and also rotate with a little extra 10%. It's 100%. It's asking the motor to go 110%.
So you're clamping forward motion to 60, and then allowing it to go to 70 when required.
Well, I'm scaling it down to 60 for all of it. But before the problem, and we can scale it to 100.
Scale to everything.
Yeah, we're scaling the whole thing. But before the problem is I said, I'm scaling it to 60, but it might actually tell it to go 70, which doesn't work as soon as we go to 100, because now we're asking the motor do 110%. And the guy's like, this isn't like a sports thing. We can't just do 110%, man. So so that's. But then what happens, because their Mecanum wheels need to be relatively correct, that it's going to drift incorrectly. So we're saying move this direction to rotate this speed, and it's just going to do something whack because we're asking to do it 110%. It's like I can't do that, so the ratio will be off. So this should account for that, and I'm going to run it.
That's it.
Let's do it. Hit it and quit it. All right, let's go.
Give me a second. Let me set up the camera.
Okay.
How's that angle? A little low. What's that angle?
That looks good. How about
Something like that.
there? Yeah, that's good.
Don't do it yet. You have the controller in your hand.
Yeah, I do. Are you ready?
Video. All right, hit it. Whenever you're ready. Do some translation stuff in German. Beautiful. Beautiful.
Oh, I need to. I think I need to scale this up. So actually, it doesn't rotate unless I give gas. So like right now, left and right doesn't rotate at all.
Interesting.
But if I give it gas, you can see it does rotate. So it's because it's too low.
Let's see.
Maybe that makes sense actually, because the only speed I get. Yeah, that actually makes sense because all we're doing here is adding to it. But the actual speed that we're using
Is the forward speed.
is the forward speed.
Or the alternative speed. Does it feel okay? Like that? But I feel like I want it to be able to rotate.
No, it should. So that's a bug. So what did I change? We tapered it down. We normalized it. Let's see. So let's say I gave it the value 1. So I put in here rotate 1, but I've given it 0 speed. Okay, so that's...
It feels so unnatural the way it moves.
Isn't it great? So if we, I think the problem is the speed coefficient. So we're essentially giving it a 0 speed coefficient because the rest of it isn't moving. So the speed coefficient right now is derived by here. The minimum between.
So it should just be an if other is 0.
Well, I don't want to have if because then you reach like a threshold and it changes behavior.
Right.
As long as it's
Good
like
point.
this mathematical thing, like it flows between these different states. So right here, we calculate the distance between the 2 points. So our dead zone and 0 zone in the controller and wherever else we're going. So we have the absolute distance in like Euclidean distance. We times it by 60 because the distance is a measure of 0 to 1 or 0.8 or whatever it was. We times by 60 to get the full force of that. Actually, that's a good point. We should change this. This distance between points, it's not going to ever max out. If you go at 45-degree angle, it will never be 100.
That's true.
And I would like it to be. You should be able to drive full speed at 100%. Because the rest of the math will already downscale it.
Yeah, I see what you mean.
So that's another bug. We have to fix that later. So now we have it at 60. But let's say we don't do anything in the motion, and we only apply rotation. So rotation, we're passing. Let's say we give you 1. So you pass in the value 1. We pass in the value 0 for move with angle. So we have some angle. Let's just say it's 0 because it doesn't matter. It's not being used. We have speed coefficient also 0 because it's not being used. And we have rotational loss. Let's say it's 1. So we have -1, +1, -1, +1. And let's say 0. Or something along those lines. And then we get down to here and we say times it by something, which is also 0. So we need to have what would we want if you do not apply any translation and you said full rotation? They should essentially feed off of each other, right? So like if I were to do max both, if I were to do full rotation right and full translation right, then I got like 200% usage. We don't want that. Like so, what I could do is
You could just
say
you say it's already a 1 instead of a 0, so the multiplication. Because a 1 is basically nothing on the scale of 100. And you're adding, so we just add a 1. But if you multiply,
we could put the minimum of either. We could either multiply, like you're saying, or
well, because like right now, the reason you're not getting rotation is because you're multiplying by 0.
right. And we're only getting speed of direction if we're not using.
Yeah, but you're multiplying by 0. If you just change that 0 to a 1, that's 1%. 1% is not going to add anything.
Well, the 0 and 1 is 0 and 100%. Just say.
I know the gap is 100%. That's what I mean, though. So like if you initialize the rotation to a 1 out of 100.
Oh.
And then your multiplication would be multiplied by 1 instead of 0.
It's also small. I think what I want is either they both contribute to this absolute speed 50%, or they are additive and then we clamp it at 100%. So like what I mean is if you were to go full right translation and full right rotation, so you now have a 1 plus a 1, that's a 2.
Yeah. So
we have a 2 in a spectrum of 0 to 1.
Yeah.
Then just say it cuts off at 1. But let's say they both were at half speed, it would be a 1. So it would be full speed to accomplish whatever rotation you need.
Yeah.
Something along those lines. So like at minimum, so like that way if you were doing full translation, you can access the full spectrum. If you do full rotation, you can access the full spectrum. And if you do them both, it will clamp the spectrum at 100%. So like the range. So I think that
So if you do, if the rotation was at 30%, just a second. If the rotation was at 30% throttle and the forward direction is at 50% throttle, on a scale of you'd have to like relate the two of them such that the 30%, like if they're both 100%, You would want them both to be 50% of the total energy available.
Yeah, try this.
Would you get? Would you?
So I calculated the absolute value of the rotation. So like it's between -1 and 1.
Yeah.
So I just absolute valued it. So we have between 0 and 1.
Yep.
And then I added them together and then clamped them at the top being 1.
Added them together, clamped them at 1.
So it's essentially like they themselves could go up to 200%.
Yeah.
But it won't because it will go maximum 1. So this should work. If you just rotate. But nothing works. Oh, sorry.
No.
This is at 100.
Yeah.
Give me a sec. Try it now. Yeah, that should be good. Oh, that's it.
Yeah. What's your overall clamp at? Like,
Actually, you know what? Can you put it in the middle and rotate it? Why is it doing that? Look at that.
It's like crab walking. So your rotation, only 2 of the wheels are responding in your rotation. The matching wheels are responding. That's a weird one.
That's a weird one. So what we had before. So front right motor is wheel 2 speed. Yeah, it is. Back left. Back left speed. It's wheel 2 speed. That's negative. That's positive. Okay, so that looks all. Sorry, come on. So, it's not going in reverse. This should go in reverse.
That's reverse. That's reverse? No.
Reverse. What in the flip?
You just
So what do I expect? I expect if I do this, I want the back. So the front does it, the back does it. Front does it, back does it. Front does it, back does it. What? What if my normalization is wrong?
see.
Just rotation.
Yeah. So that's check.
What? When's your hockey, by the way? When do you have to leave for that?
It's at 11. What time is it now?
Finish.
I'll probably leave 10.
I feel like it's clipping. I don't know why. So this definitely supports. If it's positive, it goes forward. If it's negative, it goes backwards. It does that. It does that well. So that seems to work. So it's a matter of the motors it's picking. So if we go, it only does front.
Minus, you're subtracting too much. Minus rotation velocity. It's probably making it 0.
So yeah. Well, why would it make them both 0?
Front, which one? So if I do this, if I do to the right, the back wheels are off. And the back wheels, so if I go to the right, so back left, front left. No, that doesn't make sense. They're matched the way I wouldn't have expected for them to have the same feeling. Kind of feel like I can crab walk down the road.
Is it delayed now?
No.
Those aren't normalized at all. Oh, it's not divided by normal anyway. So, can you so go rotate right? Just hold it down.
So we don't see a change in the first two numbers. Unless I switch the direction.
I think I need to scale it differently. I think this is what I was talking about earlier when I'm not getting the minimum. Yeah. Yeah, I think this is my fault. Okay, one second. So I need to scale it between 0 and 1. I don't think I'm doing that. I think I'm scaling it so the maximum value is definitely 1, but like the to 0 isn't correct. Like it's not.
Like your relationship is off.
Yeah.
Your relative relationship between motors is off.
Yeah. So. So I have the minimum speed. I'm going to, instead of absolute valuing, so let's say I have one motor that's going 1 and one motor that's negative. I want them both to be scaled between 0 and 1. So I actually want to get, if I have the minimum value is -1 and the top one is this, I want to minus -1 such that the top one is now 2. So now it's, so okay, that makes sense. So I'm going to go speed minus min speed. So what that means is what was,
Oh, you're scaling to 2.
yeah, so I'm scaling to 2. Then I get the max. Now the max is 2. So now I need to take all my other values and push them up. I need to subtract, so I need to push them all up so they don't have that front. So now they start at 0. And then that highest one, I'm going to divide by 2. I'm going to do this in a crappy way, and then I'm going to fix it later. Just don't look, because I hate this.
Fuck. Look at this. She's fucked.
She's fucked.
Like, look.
Is it
Backwards is this?
What the fuck? I didn't change that. Go away. Alright, stop for a sec.
That was
Oh no.
that was rough.
That was big oof.
Not even close.
I think it did what I wanted though.
Did it?
Um,
I don't believe you.
where'd the controller go?
Beside you.
It's like trying to run out the door. Oh no! What happened? Did I kill it? So I jigged the battery. No, it's back. Not having that. Hold it.
Sure. Forward. Oh, jumpins.
Doesn't even print properly anymore. What in the world? Okay. Front left. So what ones are not working right now? Back.
The backs. Yep.
So the
The changing numbers aren't what you're interested in right now, by the way. It's the two on the left. The fact that they're not moving.
I think it's because they're the highest.
Like change your go the other way. So you're only applying left. Front left speed.
Actually, I guess I could just change this. This needs to be between -1 and 1. Boom, now it's correct. But is that what I want? Move the speed. -1 and 1. Yeah, it is. Okay, so that's actually fine. I don't need this thing. But this is still. So the front wheels has the most juice. And why is that? Front wheels. So front, these are two different things, and they have the rotations in the opposite direction. It's because it's getting closer to 0. Can you hold it up?
What is that?
You know. No, restart.
So for everybody in the chat, what's happening or what we're experiencing, don't know why, but what we're experiencing right now is instead of having all four wheels rotating in the same direction, like same relative direction as far as clockwise and counterclockwise goes, we only have the front wheels operating when we're turning right. We only have the back wheels operating when we're turning left, which technically gets the rotation, but it doesn't do the rotation with the speed or the, I guess it's called pinpoint accuracy that we would expect.
Well, yeah, I would expect them to be in reverse. So we would expect. Okay, I have another idea. From now on, all you do is rotate. Do you do it well?
So they were canceling. Why were they canceling? So velocity. What was the other information? The other information was wheel pair speed. If the speed and the rotation velocity are the same value and you're subtracting them.
I think we need to. I think here. Yeah. This is the problem. We have one speed coefficient.
Yeah, and they're taking both of them. They're just canceling each other.
Yeah.
So like if this one's positive and this one's negative.
Yeah, we need two different speed coefficients. Okay, so yeah, and that helps a lot. Yeah, I think that's it. So the problem that I'm seeing here. So obviously, when we just do rotation, it looks perfect. If we just do translation, it works perfect. If we put them together, it doesn't. And I think that might be because of how much they're contributing. So like if we don't even put any. If we just give it wheel angle 0 with strength 0, whatever, by default, its default is to cancel each other out for those things. So I think what we actually need to do is have this be weighted based off the speed. We actually have two speed coefficients. Wheel, like the wheel angle is actually a terrible word for it now. So translation angle. And we have rotation angle. So let me just see this speed coefficient.
Yeah, so it'd just be the, yeah. Wait, so you're only taking one speed coefficient. How does that work? Because there's two joysticks.
Exactly. That's the problem, I think. So I think one, it was just because it wasn't breaking it down enough. So it didn't know what contributed to it.
So it was only taking one, and it was just randomly choosing between the two.
It was putting them both, but I think it wasn't even. Like it was treating it evenly. Like I was essentially giving no translation and having positive rotation, but it was weighing the rotation too highly, and the rotation wasn't meant to do anything. It should have been at 0. It was like what should have happened is this wheel pair speed should have canceled out because it should have been multiplied by 0 somewhere. Because we actually have no, like, sure, whatever angle, the wheel angle we put in there, great, do your math, but times it by 0 because we're not giving you any speed to it. So we need two of these speed coefficients here. I think that's what it's going to be, so they don't cancel each other out. So right now we have this where it says just pick, essentially just get the best speed. We don't actually want to do that. We actually want to split them up. So we have rotation speed and normal speed, I suppose. Here, translation speed.
Interesting one.
think that's what it is. Like, even if this isn't it, this should still be done because we were valuing something which should have been 0, essentially, in our equation. So what I mean by that is this speed, we're going this speed times that. Does that make sense? No, not yet, because where did that times with 60 come out? Happens here. Yeah, so we don't want that yet. So we're going to make this equal to 60. I should change a couple things around. All right, and then we have rotation speed. So now we have this value that is weighted. By weighted, it means this. So let's say we're not using the left joystick, which is for translation. If we're not using it, its weight value is 0. So this value here is 0. So you multiply the weight by whatever particular thing you're working on. So 0 times this cancels it out. If we're only rotating, it's going to be 1. So if it's 1, or positive at least, we're going to actually weigh that rotational velocity more. So that should help. This is going to be used down below. So that's just constant for both of them. It doesn't really matter.
It's just our maximum output.
It's our maximum, yeah.
We're limiting our motors to 60% so we don't shake the car apart.
Yeah, as we have been doing. Shaking it apart. So that looks good. Minimum. This shouldn't be. It should be minimum to 1, I think, actually. So this is just clamping it to make sure it doesn't go too high, which we'll change around later. That multiplies it. That goes to there. And we can still multiply it. I think that's it.
What do you expect? It's hard to really tell if it's doing the right things when you're not holding the controller. It's such unnatural movement.
It works. I don't know if I want it to. I think I want rotation to weigh more. If you like to.
Well, if I'm driving,
This is like a sensitivity. No sensitivity.
yeah, I'll let you explain this. The rotation works, driving works, the driving and rotating doesn't really work. It's just turning.
Right, because they're both contributing. Oh, connects. Okay, bud. There we go. He's like, what's going on here?
Hey, puppy.
Okay. So, like, if you were to go fully rotating and just slightly, the more you move, the less it rotates. Well, we could,
Yeah, I think you're right.
so we could just scale it up, though, right? Like right now, they're effectively equal. So, like, we have weights solely based off of what the joysticks are saying.
Mm-hmm.
And the weight is between 0 and 1, or 0 and 100%, let's say. But we can also say, I want this weight to mean more than that. So we can have the weight based on the joystick value and scale it even further to mean rotation so the precedent is higher.
Mm-hmm.
So and that's as simple as can I just multiply these actually?
I don't understand why 2 of the wheels stop moving. Oh, because they're canceling. I see. Yeah.
So we fix that.
So they're canceling now. Like that's them canceling
Yeah.
on the left side.
I think it's because I still want to move forward.
Yeah. Well, forward requires all 4 wheels to go forward, but rotation requires 2 of them to go backward. Backward
Yeah.
plus forward equals 0.
Yeah. So it's the best compromise.
Yeah.
Less rotational speed.
That makes sense.
So now it's a matter of making it feel good. don't know if that helps.
We just wanted to, like, the question is, like, I think what we want is for it to turn very quickly.
Yeah.
So yeah, just ramp turning at
Quite a bit.
literally. I almost think that you can quit literally. Oops.
Looks like I just killed it for you. Try it again.
So basically now you have it as stop driving and rotate.
10 times the weight for it.
So stop driving and start turning.
But it's not like if this then stop, it's open. It's just the math works out. So does this feel better?
Yeah.
It's like the Roomba. It's pretty scary, eh? Come on, man. He's like, I'm out of here. Alright, good point. It seems like it's doing it very sharply. Is it too much?
What can I describe? I don't like that it stops to turn.
It's too much.
Yeah.
Yeah, 1 second.
It's-
Oops, sorry. No, it's just I scaled it. I scaled it to 10. So, because what ends up essentially like it, we just removed the decimal point of the other one. I made it set to 3 times. Do you mind?
You have it at 3 times? Do it 2 times.
Good job in the car, Max. Yeah. All right, let's do it 2 times.
I mean, it feels good. It kind of feels like a drone, in the sense that it moves. Like, actually, this is literally drone control when you think about it. Just translations and rotations almost separately.
Yeah. That feels weird.
It does feel weird, doesn't it?
You know what? Sometimes you gotta put a jetpack on. You know what's happening.
What you've wanted right from the beginning.
I need speed.
The battery's probably dying by now.
Holy shit, this is stupid. What the fuck? I can't even drive this. What the fuck? Oh god. This is the wrong box for this. But it helps, right? As soon as you keep up speed. Like, do you want to go back down to 1-1? It's Cheetah. Frig. That's incredible. Alright. I'm gonna check on the screws before it falls apart.
We made it dance.
We made it dance! We made it dance, everyone! As promised. Is the motor falling off? Good work, man.
Everything's good.
Dude, nice work. Boom.
Dang.
Alright. So I would suggest we have control now.
We should.
I think it's actually too much.
Too much power.
Too much turning. I want to see what it's like at 1-1. But yeah, you're saying we have control now.
So we have control now, and we should basically set this up and say like, okay, as far as an RC car goes, we're done. Or a Bluetooth controlled car, we're done. So now next step is to start working on taking away the PlayStation controller and starting to work on an actual software implementation, an autonomous software implementation. Does that feel better? Looks better.
Oh shit! I was off.
Careful. We should install a bumper.
Good point. Yeah. So when we're 100%, it does feel better with the turning. But that's this is stupid.
Alright. What else did we say we'd get done? Alright, stop for a second.
It's so loud. What's that? Drifting. Oh no! Oh yes. No. It just drives so weird.
It does drive weird. Alright.
I love it. This is awesome.
That is cool.
Holy shit, it is windy. I don't know if you can see this. This feels great. Yeah, I'm way too excited now. This is so cool.
That was great.
Exciting.
So at the start of the stream, we talked about what our what our objectives were. We said that we would get our PlayStation controller connected to the car. That was quick and easy. About 6 hours ago. We said that we would get one joystick translation. So basically, our left joystick action, which would be this. I would suggest that we check that box pretty quickly. We said that we would rewire the car to support the rotations. So originally we had 4 PWM control, but we need 8 to have individual motor control. So that allows us to do this. We said that we would test the rotation and confirm that 8 PWM control actually works, which again, this. And then we had a broad statement, which was determine the math required for rotation and translation integration. So that is basically driving, turning, and translating. And all of those things seem to work. And then the last step on our objectives list was to test all of those things with the PS4 controller. I would say we hit all of our objectives for this stream. I think that was a great day.
That was sweet.
So our upcoming stream would probably we'll probably integrate the camera and start trying to implement some likely OpenCV on the camera and try and introduce some machine learning.
Suggestions welcome.
And yes, yeah, exactly. Try and introduce some machine learning and object detection / avoidance, or even object tracking. As far as that, we may also use the wheel encoders to track distance traveled, or we might try and do that with an IMU. Not sure yet.
I think even if we could just get it to avoid objects would be great. Whether it be via camera or ultrasonic sensor. It's almost too fast.
What we could do, maybe what we'll do is keep control with the PlayStation controller first, add some sort of sensory capabilities like
That we can read.
and basically try and drive into a wall and have it shut down before it drives into the wall.
So it's like assisted driving.
Assisted driving. Yeah, we'll develop assisted driving first. That makes sense.
I like it. It's first step.
Cool. That's what they're doing in real world. Assisted driving, lane tracking,
I like it.
vehicle detection. What do they call
We
it?
could do lane change. Just draw some lines, just open TV for the lines, and actually
Just have it lane change. Like this.
it would just translate though.
I wish. I don't know why it turns. Is it turning because it's slipping, or is it turning because one of the motors is pulling harder?
or that.
Or am I?
Do you mind?
Interesting. We should almost graph the output to all the motors to see where we would anticipate it to go versus where it actually goes in real life. Like if
This isn't done properly, I don't think. We normalize it to 0 and 1. Yeah, this still isn't finished yet. Because I broke it when I changed this code. We normalize to 0 and 1, and then we multiply by the speed coefficient, which I hard coded to 100. Before, it was 100 times the magnitude of one of these guys. So right now, well, and if I do this, it's 0 to 100 like immediately.
yeah.
It's always 100 right now.
Oh, there's no.
Yeah, there's a bug. I just realized because it wasn't behaving properly.
It was just going as fast as it could always.
Always.
Interesting.
So it could be a lot smoother.
Sweet.
All
Can we
right.
fix it?
Yeah, let's fix it. So what would we want if it was going to be a fix? I think something like even this.
Do you think there'd be a possibility of like using one of the? We don't have to do it today, but using one of the buttons on the PlayStation,
Like the triggers?
like X. I don't mean for throttle. I mean like if we just use X to go through speed settings. Like it'd be like, oh, if you want 100, or use the D-pad for speed settings. If you want 100% speed, press up. If you want 50% speed, press down. Like
I suppose.
Let's say-
Ideally, we just leave it. We have the full range here, and we just are careful. But yeah, we could do that. Where then it would limit us.
then we could limit it ourselves.
Yeah,
It
and
could
not
be
have,
like
not have to
shifting
worry
your
so
car.
much.
Yeah.
Yeah, like shifting your car.
That's not how that's supposed to work.
Whoops.
Speed cost. Speed cost? Speed cost.
See, now I go slowly. So now it's fluid.
I lose track of where I'm at.
I know, right? It's so fast. And it's hard to know where the front is, too.
Yeah, that's the thing. I gotta stop doing that, like hard shifts.
But it still does it. The motor's
Oh.
like no big deal.
The motor doesn't care. It's just there's not enough friction for it to pick up quick enough. And it's interesting. I was actually just talking to. I sent my dad a picture of it, and I was talking to him about the rollers. And one of the big things where we lose a lot of traction due to the rollers, our biggest trade-off is basically the fact that the rollers are tapered to the center. So that means that the only contact point of the roller is a very small portion.
Well, the surface area is small.
The
It's rather like a normal tire, you have a big thing and it like deforms to flatten on the ground.
Exactly. We have basically no deformation and a much smaller surface area. So our traction is very small in comparison.
Oh man, that's a good point.
That's the trade-off. I mean, every set of wheels, every type of wheel has a trade-off.
And that's it for this guy.
Yeah.
Not bad.
Anyway, I think that's probably a good place to call it.
We got it working. We fixed the bug. It seems to drive everything we want properly. Anything else anyone wants us to test before? Or any questions about the code of the hardware?
Let me give him a few seconds to hop in.
Yeah, I was gonna play around with it until then. This is sweet. Like, I love it just like stopping over.
Yeah, I want to take one more video of it.
You know what? Oh shit! You know what I found? As soon as I started driving it, and we had the rotation, I'm driving it straight with rotation because that's what's intuitive based on other cars. I'm not even using the train. Like, there's so much cooler ways to drive this.
Yeah.
Like, look at how you can drive it. That's the pushing power. Love the way it turns.
Yeah, that's incredible. Yeah, I guess that. All right, let's call the stream there.
Let's call it, everyone. This is awesome. I hope you enjoyed as much as we did. I cannot wait for the next one.
Yeah, this was a big day. This was a big success. I would suggest that, for all intents and purposes, we've successfully made a Bluetooth-controlled remote control car. Yeah. So next step is work toward autonomous
We'll probably have to go pick up beer.
and pick up beer.
It's going to be a good time.
All right, everybody. Thanks so much for watching. Thanks for sticking around. Anybody who did. Thanks for stopping in. If you're here and you're just popping in and out, thanks for lurking. If you're lurking,
We hope you
Appreciate
learned
it.
something.
yeah.